Hello guys, welcome to our math lesson, and today's topic is statistics. You will be able to define statistics as a branch of mathematics and state the activities it involves, describe some different methods of collecting data, present and interpret data by using graphs. Okay, we will divide this lesson into two parts, A, basic concepts, and the B, presenting and interpreting data. Okay, what is statistics? Statistics is a science of collecting, organizing, summarizing, and analyzing data, and drawing conclusions from this data. Statistics is a discipline that evaluates the reliability of numerical information, called data. We use statistics to describe what is happening and to make projections concerning what will happen in the future. Statistics show the results of our experience. Many different people such as economists, engineers, geographers, biologists, physicists, and managers use statistics in their work. Okay, look at the definition. Statistics is a branch of mathematics which deals with the collection, analysis, interpretation, and representation of masses of numerical data. The word statistics comes from the Latin word statisticus, meaning of the state. The steps of statistical analysis involve collecting information, evaluating it, and drawing conclusions. For example, the information might be about what teenagers prefer to eat for breakfast, the population of a city over a certain period, the quality of drinking water in different countries of the world, the number of items produced in a factory. Okay, and the second is collecting data. We can collect data in many different ways. First, A, questionnaires, B, sampling, and the C, surveys. Okay, first one, questionnaires. A questionnaire is a list of questions about the given topic. It is usually printed on a piece of paper so that the answers can be recorded. For example, suppose you want to find out about the television viewing habits of teachers. You could prepare a list of questions such as: do you watch television every day? Do you watch television in the morning or in the evening? What is your favorite television program? Etc. Some questions will have a yes or no answer. Other questions might ask a person to choose an answer from a list or to give a free answer. When you are writing a questionnaire, keep the following points in mind. First, a questionnaire should not be too long. Second, it should contain all the questions needed to cover the subject you are studying. Third, the questions should be easy to understand. Fourth, most questions should only require a yes/no answer, a tick in a box or circle around in choice. Okay, second one, sampling. A sample is a group of subjects selected from a population. Suppose the population for our study about television is all the teachers in a particular city. Obviously, it will be very difficult to interview every teacher in the city individually. Instead, we could choose a smaller group of teachers to interview, for example, 5 teachers from each school. These teachers will be the sample of our study. We could say that the habits of teachers in the sample are probably the same as the habits of all the teachers in the city. The process of choosing a sample from a population is called sampling. When we sample a population, we need to make sure that the sample is an accurate one. For example, if we are choosing 5 teachers from each school to represent all the teachers in a city, we will need to make sure that the sample includes teachers of different ages in different parts of the city. When we have chosen an accurate sample for our study, we can collect the data we need and apply statistical methods to make statements about the whole population. Okay, third one is surveys. One of the most common methods of collecting data is the use of surveys. Surveys can be carried out using a variety of methods. Three of the most common methods are the telephone survey and mailed questionnaire and the personal interview. Okay, third one, summarizing data. In order to describe a situation, draw conclusions or make predictions about events, the researcher must organize the data in a meaningful way. One convenient way of organizing the data is by using a frequency distribution table. A frequency distribution table consists of two rows or columns. One row or column shows the data values x and the other shows the frequency of each value f. The frequency of a value is the number of times it occurs in the dataset. For example, imagine that 25 students took a math test and received the following marks. The following table shows the frequency distribution of these marks. It is a frequency distribution table. We can see from the table that the frequency of 7 is 3 and the frequency of 8 is 5. The sum of the frequencies is equal to the total number of marks, 25. The number of students took tests is called the sample size, n. In this example, the sample size is 25. The sum of the frequencies and the sample size are the same. Look at example. 25 students were given a blood test to determine their blood type. The data set was as follows. Construct a frequency distribution table of the data and find the percentage of each blood type. Okay, there are 4 blood types, A, B, O, and AB. These types will be used as the classes for the distribution. The frequency distribution table is this. Okay, we can start this table from this given information. To find the percentage, we can use the following formula. For example, in the class for type A blood, the percentage is 4 divided by 25 multiplying by 100, and it is equal to 16%. Presenting and interpreting data. First one, bar graph. The most common type of graph is a bar graph, also called a histogram. A bar graph uses rectangular bars to represent data. The length of each bar in the graph shows the frequency or size of a corresponding data value. Look at the example. The following table shows the marks that a student received at the end of the year in different school subjects. Draw a vertical bar graph for the data in the table. We begin by drawing a vertical scale to show the marks and a horizontal scale to show subjects. Then we can draw bars to show the marks for each subject. Okay, second one, line graph. We can make a line graph, also called a broken line graph, by drawing line segments to join the tops of the bars in a bar graph. For example, look at the line graph of the data from previous example. To draw the line graph, we mark the middle point of the top of each bar and join up the points with straight lines. And the third one is circle graph or pie chart. We can also use a circle graph to represent data. A circle graph uses a circle to represent the total of all the data categories. The circle is divided into sectors or weights, like pieces of a pie, so that the size of each sector shows the relative size of each category. Circle graphs are useful for comparing the size of frequency of each result in a sample. We use a protractor to draw a circle graph. The central angle for each sector of the graph is given by the formula. Central angle is equal to f over n multiplied by 360 degrees, where f is the frequency of the result and the n is the total number of results in the sample. For example, a student calculates the number of hours she spent doing different activities during a period of 24 hours. The results are shown in the table opposite. There are 24 hours in a day, so we will divide the circle into 24. N will be equal to 24. The central angle for each sector is this one. We calculate each one by using a formula. Now we can use a protractor to graph each section and write its name and the corresponding percentage. Okay guys, it is not hard lesson for you. I think you understand all the informations from this lesson. Thank you for watching. See you on the next video. Goodbye.